Welcome. I'm Dale Walkonen, and this is Facing Future. After water, concrete is this world's second most consumed material, accounting for some 8% of global emissions and producing over 4 billion tons of carbon dioxide every year. Much of the world's infrastructure is made up of concrete with a 50 or even 100-year lifespan that is now deteriorating and cracking. Increasing structural durability to a 500-year span would have a significant impact on the environment, requiring that less concrete be produced while restoring older structures. Our guest today, Martin Halliwell, has over 10 patents designed to lower CO2 in the making of structures in what he calls earth-honoring systems, like FEGO Wind, an off-the-grid windmill that integrates geothermal installation. My co-host today is climate scientist Paul Beckwith. Welcome to you both. Martin,
Hello.
Can you tell us what you've been able to do to tame the climate monster that is concrete?
Well, it's certainly been a journey. I've observed things in concrete over the years that I think need to be rectified, and I think they are largely being rectified by companies that are innovative. Concrete will crack from the ingress usually of salts. Let's say we have, for instance, we have P3 projects that are advocated at 1.2 meter walls of concrete. 1.2.
Can you define what is a P3 project?
A P3 is build, own, operate. So in order to reduce the burden on taxpayers, the TTC wanted to have trains and subways again. So they said, well, we'll go to people that can bond these jobs, and what you end up with is two bidders, and you end up with engineers for those two bidders that are worldwide companies. There's no incentive to design it in a leaner way. Once you're a low bidder, you've got a job for 5 or 6 years. And they've advocated, for instance, that we should have 1.2 meter walls and 1.5 meter base slabs in relatively dry clay. And every cubic meter of concrete, by code that these large engineers have pushed for, have 2,400 kilograms of rebar per cubic meter of concrete, which is a really dense mat of rebar. So the real trick is to get rid of rebar, and in terms of reduce it, not over design things. So that'd be my first comment. We can talk about, let's say, what innovative companies are doing. There's a company in, Paul might have heard of it, called MST Rebar, and they're doing, I think $400 million a year in glass rebar. So that glass rebar doesn't expand and contract with temperature. So you end up with a stiffer product and something that naturally would reduce the cracking, because cracking is caused by the temperature and expansion of rebar and by the ingress of salts.
Rebar is normally made of steel?
Yes.
Yeah. How do you make it out of glass? It's strong. Glass is, are you talking about glass fibers or something?
Yeah, Paul, MST Rebar, it's worth looking at sites.
Okay. Okay.
And the gentleman is quite an innovative guy, backed by some pretty good money. So he's really got something going. So he takes glass fiber, Paul, and he melts it, and then he extrudes it into bar.
Okay.
So it comes out, and he can bend it. You have to bend it hot. You can't really bend it cold.
Right.
But once you bend it hot, you get this tremendously stiff potential. I think it's 4 times stiffer. So with the load, deflect 1/4 less. It literally doesn't move.
Okay.
So we're doing slabs now that you put in a relatively small amount of MST bar, and you don't need to cut the slab. So if you don't need to cut the slab, then that's a good way to stop ingress. And if you're naturally not going to expand and contract with temperature, then they're getting the market, right? People are waking up to it. Matter of fact, the Ministry of Transportation has largely flat spec that bar now, and bridges. So the hope is that the bridges, the Don Valley Parkway, for instance, we've spent years and years repairing it. And, if we build it right on the new additions, then you're not going to see the ingress of road salt. And
Okay, a couple quick, let me just clarify things. I know you know, but for the listeners and stuff, is the concrete's very strong under compression. So if you're pouring it for a floor, you're okay. You don't need rebar. Is that correct? And if you're doing it for a wall or a bridge, concrete's very weak under expansion. It'll just crumble, break apart, crack. So you need the rebar to hold it together, whether it be
Yes.
glass or fire. And you're saying glass doesn't expand with temperature and it doesn't corrode with salt, so it's better. But I mean, concrete, why don't we, is a 50-year lifespan, is that an accurate number for, but I mean, it depends on conditions, of course, usage and all kinds of different factors. But I always wonder why we can't build concrete that lasts much longer, like the Romans did, Roman concrete. Why don't we do that?
Well, I think that the trick with the Roman concrete was that they had a unique fly ash from the volcanic source, and that was credited with being able to do shapes and aqueducts and whatnot that are around today. So,
Right.
but they also didn't put rebar in it. So this
Right.
idea of putting rebar in something is going to break it apart. So there's hope with MST rebar. There's also hope with patents that exist, relatively new patents, Paul, that exist in the world for admixtures that won't let the water in.
The admixture is what you add. So you have cement and you add a mixture, rock, gravel, whatever, stones to the
Cement.
cement, and then that forms the concrete, right? So I've heard that there's different types of I mean, you have some patents on admixtures, and there's some companies where you could actually add a small percentage of something to the water they're using to mix with the concrete to make it less porous, the concrete. Is that true? Or
Yes, they're called chemical admixtures. So there's chemicals
okay. Okay.
so you got water, gravel, cement, and usually the standard is Portland cement. So
Right.
there's a cement called K1 cement, which claims to use a certain amount of rock dust. But the real progress is being made now with the MST rebar, and I've been advocating the use of chem concrete waterproof hybrid, which was developed at the University of West Sydney in Australia by some Iranian engineers. We know they're pretty good engineers, and they've got a 5 hybrid nano, and they've actually taken the admixture market and kind of given it a big shock in the sense that crystallines have been the traditional effort at trying to put something in that builds crystals in the matrix. Well, Crichton and Zypex, which are billion-dollar companies, they're actually Canadian companies and they're worldwide. They come out of Vancouver. So now there's a new kid on the block, and if you look at the permeability improvement with crystalline is probably 35%, but with chem concrete, they're over 90%. So now we have the potential as systems thinkers to say, well, why not? Why not make this stuff last? And I think, Paul, it's 200 years is what's possible here.
Okay.
I mean, long enough that 50 would be an old standard. So.
Okay. Now I understand that the greenhouse gas.
Hold on a second, Paul. In your website, you're talking about a 500-year lifespan for concrete.
Well, I am, yeah, because I think that if people would listen to me, we could do it. But also, I've been on this path for a while. I had a couple of patent efforts at trying to create a mix. It's hard to do. So when the Australians came up with the world patent, truly unique, then I would just say, for the love of the planet, I don't need to push my own patent, right, commercially. It's hard to get people to change what they're doing chemically in concrete in Toronto, and it'll be hard to get chem concrete accepted. But MST bar's on its way, and chem concrete's on its way. So the two together neither one of them involve any patents I have. I have system patents that involve, let's say, using drilled shafts and having less concrete. So those would
Is
be.
there any, there are some concrete innovations like hempcrete, concrete that doesn't require, a 1400 degree Fahrenheit or a centigrade, I guess, furnace. Is there some way of getting around that enormous amount of energy that's required to produce concrete?
Yes, I think I would say that the Portland cement industry is, well connected, and there's a lot of industry process that's well developed. We can do things with basaltic fibers, for instance, that are really, because the goal is to have low permeability and no cracks. So if you're using steel rebar and you cause cracks by temperature expansion, you're in the wrong direction. And if you're using admixture that's, let's say, only crystalline, when now there's a better product, then that'll take some time, but I think that it will own the market.
I've heard of some kinds of concrete that actually sequester CO2 or that continue in their lifetime to absorb CO2. Are you familiar with any of that?
Well, the inference there would be that if you can absorb CO2, I think it's a racket myself, but if you can absorb CO2, then it's porous. So in other words, when have you seen, let's say, something where you pour water on it and it just soaks in, right? Well, the chem concrete actually beads water. So it's chem concrete, USA.com is my friend Jim Kaler. And they've now sort of set up main distributors in every country.
So let me understand something about the distribution of concrete around the world, because Gail's already said it's the second most consumed material on the planet and 8% of global emissions. So you start with limestone and some sort of clay or something, right? You mix them in the kiln, 1450 or 1500 Celsius, and then you produce, it's called sintering, and then you produce these clinker, right? These small nodules. Now, and then to make cement, you grind the clinker with gypsum, and that makes cement, and then you mix the cement with the admix to make the concrete. Have I got that basically right? So what is shipped around the world in ships to places that don't make their own, or are most places, obviously because it's so heavy, you want to make the concrete where you use it, right? To have a lower footprint transportation wise. Is that being done, or is this clinker shipped around the world, or am I missing something completely?
Well, aggregate's generally local, right?
Right.
So
The aggregate. Okay.
the gravel is going to come in from a local pit. So
Right.
and then the plants like St. Mary's Cement or these plants that they're huge, and their processes are making Portland cement.
Right.
So what comes in on ships is probably not from another country to make Portland cement, because everybody's making the same Portland cement
Around the world. Okay.
Yeah, needs gravel locally to reduce their costs, because it's all about the turn time for the truck. The truck, the dump truck comes in there, and then they have silos of different material. You try to get quality sands. That's an issue for our planet is, a lot of these sources are starting to be hollowed out.
Yeah, you need lots of material, right? So it's, I mean,
is there a lack of sand, the right kind of sand? That was a problem that has been mentioned often, that we're running out of the sand that is used to produce concrete.
Yes, I couldn't really give you statistics, but that's a common. It gets harder and harder. So let's say if you don't have the perfect sand, then you have to make the sand. So you might have to pulverize and create something that's of sufficient quality that it's going to bind in the same mixture and with the same chemicals. You might have to adjust your chemicals for that, but I think the ideal sand is always something that's found and mined out and then capped.
So would each country with large cement projects have their own kilns and basically start from scratch to avoid shipping stuff around the world? Or would if you don't have a kiln, then you need to import concrete in what form? Portland cement or the clinker, like the precursor? I'm just wondering, like maybe the
I think it is
transportation. Yeah.
probably Portland cement, Paul.
Okay. Okay.
Like there
So-
would be countries that wouldn't invest in a cement plant, and that projects that are remote. So you know, whatever it takes to get, let's say, the nearest quality Portland from another country, or yeah.
Okay, now is it true that the emissions, as far as the CO2 emissions are going, I mean, we built a lot of infrastructure out of concrete at about the same time when we built huge cities and stuff. So if the lifetime is, you know, say 50 years, after 50 years, you pretty much have to replace everything. I mean, is this a sort of an ongoing problem? I mean, China's building huge cities seemingly overnight out of huge concrete. So, you know, unless you're, I guess the lifetime depends a lot on the usage, as we talked about. I'm just, I don't know. I mean, I heard recently that China's in a bit of a real estate slump, so their concrete consumption production has declined 25% in the last few years. You know, they're in a bit of a lull, concrete wise. So, yeah, there's so many facets to the industry. I guess how do we what are the best ways? How do we have we removed the CO2 footprint at all for concrete and cement in the last, say, 10 years, in the last 20 years, or is it just the same as ever?
I would say, you know, it's the same as ever. You know, and that's where the MST rebar gives a lot of hope, or let's say a revolutionary admixture, where you can make it so that it would bead water. And obviously, if it can bead water, then it's not going to let in salt.
Right. So it's almost like it repels water. Like
Yeah.
it just doesn't, like, yeah, like it's water droplets on like a perfectly clean sheet of glass where it just beads and runs off. I think I have that view. Okay, so tell us, maybe Gail wants
I
to
just
chime
want to,
in.
before we close, I
Yeah.
just want to ask about even retrofitting older structures. Can you do that? Can you preserve what we've already had without having to produce more concrete?
Yes, I think that there's a rehab industry that's fairly active. So there's contractors that do rehab, and there's products that were what you would call overlays. So there's a certain process to chip down and try and make a minimum thickness on the outside. You can use shotcrete, and you can use certain mixes that have high permeability. So you can do shotcrete, which is sprayed concrete in a dry bag. You can order the bag from someone like King Packaging. I think King Packaging was recently bought by Sika, but Sika is very big, so you get this consolidation of the industries. Not necessarily a bad thing, but to some extent, it's when small companies get bought up, some of the innovation loses. You lose the innovation, and they don't necessarily improve the product. So the smaller,
And
yeah.
so tell us more about footprint engineering. I mean, I like the name. Even the name indicates that, you know, you're concerned with the CO2 coming out and you're trying to minimize it. So tell us more about your company. It's more of a construction company, contracting, or like, and your patents basically.
Yeah, I would say it's value engineering, Paul.
Yeah.
So I don't have CAD. I basically can give people advice. You know, value engineering is actionable verb, measurable noun. So, you know, we might say end rehab or something like that. But you simplify it. It's a big industry, value engineering. I
Okay.
took the first CVS course. I didn't take the second one. People will become consultants, and they'll get people together. And the idea would be to try and come up with simplification of the problem. So that's something that I've touched on, and went to the States for the first course. But I'm not interested in conducting, you know, seminars, or let's say putting MTO together. They do it all the time. So some of these bigger organizations like Hydro or MTO, or they would have value engineering exercises if they have those types of things.
Okay. So, I mean, footprint engineering, I like your acronym FENG. for footprint engineering. It sounds like you're, a Chinese company, I guess. But anyway, that's not necessarily a bad thing. But
Well,
I understand you have a farm, and you have a lot of your device. Like, I would love to visit your farm because it sounds like you have holes in the ground, and you're testing your geothermal, and you're testing your, I think there's a creek running through, and you're testing foundations. And I mean, I guess
well,
if you own the land, you can do whatever you want to it to do your trials. Is that true?
well, I sold the farm. My second wife and I parted company, but it was a hobby farm, and I have just an acre lot that's off grid, so I'm able to experiment with I did the first FE BTU cell, which is a geothermal that I think is a game changer. That's probably my best patent, Paul. So the idea would be, can we do a patent for energy that doesn't involve glycol loops in the ground, glycol leak, and doesn't involve those traditional drilling techniques. I can do more units per day at a lower cost, and the COP, coefficient of performance, it might be 2.5 with what they're doing in Toronto typically.
Okay.
And I'm well over 5 with something that you can do more units per day. So you're using a caisson drill in clay. I'm focusing on trying to sell my U.S. patents now in Texas because I don't really want to go to the U.S. So my traveling is less. Do you travel a lot, Paul?
No, nowhere near as much as not really. Maybe I go to a certain few things a year, like the climate conferences and things, but not too much. Yeah.
Yeah, no, I appreciate your work in that area.
I remember coming up and visiting you and your company years ago. So that was quite eye-opening. So your geothermal has a coefficient of performance. It operates twice as efficient as standard sort of units. And you mentioned, I looked on your website. It's great, by the way. You can say kudos to your web designer. Lots of neat stuff. And videos and music and colors, bells, and it's very straightforward too. It's easy to navigate. But you were talking about where was I going with this? Yeah, you were talking about like 10 kilowatt or something systems. Is that for your geothermal?
Typical
like
windmill.
Yeah, how deep are you going, and how does the wind fit into the geothermal? Like, usually they're separate.
Well, it became 2 patents when my patent agent recognized, he's from Ottawa, by the way, when he recognized that there's never been a windmill supported by a geothermal pile. So sometimes patents can be, uniquely positioned. So, but really it was the FE-BTU cell that created the opportunity that's robust, put in by caisson drills, which I was a caisson drill guy for years. So then you end up being able to create a water furnace, and it's like controllable by a water furnace would have about 30 psi in an inner, let's say 16 or 24-inch steel liner.
Okay, so sorry, it's like a boiler system to heat your house, right? So you've got water pipes and radiators, and your geothermal to provide the heat to the water. Is that right? The idea?
Yeah, essentially, the water furnace will work just like a regular glycol system. You've got to shield it from the elements, and you've got to still have industrial batteries. Even the windmill can charge I got 2,000 amp hours of battery, and the windmill can charge that. But even my solar system can charge that. So my batteries, you need lots of battery and industrial quality, and then you can basically tinker with servicing things, or I don't run my test site number 1. I don't run that in the winter, but in Texas it'll be a popular thing because in Texas it's all clay, so you can that's where drilled shafts came from. So the whole state is clay, and it's hot there, so they'll appreciate that kind of air conditioning. It's an amazing air conditioner in heat, and I think what we're facing is heat.
Yeah.
Would you say That's the
Yeah.
the schools are,
The heat waves. Yeah. I mean, it's starting to make many places uninhabitable. So also in Australia, I guess they're looking, some of the heat wave. I mean, they're ongoing right now, massive heat waves across a vast swath of Australia, most of Australia, for example. And, Texas. Yeah. These places are becoming, no fun to live in the summers, and a risk of to your mortality, right? I mean, you can't, yeah, it's just unbelievable because of the wet bulb temperature getting so high. So there is a huge demand, and I mean, geothermal seems to be the most efficient by far. And also, if you combine it, you're getting power from the wind on it. Have you looked at solar as well? I mean, solar electric power generation is doubling roughly every 3 years around the world. So I read recently that 90% of this photovoltaics are made in China. So it's going to be replacing all of the rest of the electrical power generation probably within a decade, this solar electric. So it's just phenomenal growth.
No doubt we're making incredible advances, hopefully, but the heating of the planet is going on apace, and we know that we're in a very critical state in terms of the global forcing that's happening with the heat. And thank you for everything you can do to mitigate some of this incredible problem with our built environment, which is rapidly overcoming nature itself. And thank you for being with us today on Facing Future. I think we're going to end there because this is about our time limit. But it was great to meet you, and
yeah.
thank you.
Anytime I can follow up and help you, let me know. Call me. I do have a solar curb patent. It heats the panels in the winter. So in other words, it's a box, an aluminum box. I put it on the roof. It's just called a solar snow curb. I learned that lesson on my farm because the snow was sat there for months. So
Yeah.
Well,
Yeah,
we'll
no,
put
it's
your website in the description so people can find you. And if you
and
want, we can put your contact information as well.
yeah,
yeah,
and just you didn't tell me, are you building a little small modular nuclear reactor on your farm as well? I mean, it sounds like you've got just about
no,
everything covered there,
I'm
Martin.
not a big believer in nuclear.
Yeah.
Although I'm
Well,
close.
there's an
I'm close
issue for
to the
another
proof.
program. Well, thank you both. And
Yeah, well, thank you. It's been a pleasure. Yeah, I've learned so much.